Good evening, everyone. I'm Yatish Batla, and in this session, I'm going to teach you how to build a microservice. So here, I have divided my slides into following section. So this session is going to start with the introduction, where I'm going to tell you the technologies which I have used for building this microservice. After that, use case. After that, how to develop or how to code this application. I will explain you the coding part, and after that, the interesting part, which is the running this microservice with the help of Docker technology. And finally, I'm going to give you an overview of the authorization part with the help of Spring Security. So what is microservice? So a microservice is a small service which is used to build a complex application, and each microservice has its own process, and each microservice is able to communicate with each other with the help of lightweight mechanisms. And this is the advantage of using a microservice in developing a complex application as compared to the monolithic application. So here I have used Spring Boot, and Spring Cloud frameworks to build these microservice. You can use either Maven or Gradle. So my project is compatible with both building tools, but for explaining this project, I have used Maven tool. So I will explain the building part in the context of Maven tool. And finally, I have used the Docker. Docker technology is used. So the jar file which is generated, which will generate after building my project with the help of Maven. So this jar is going to be converted as a Docker image, and then this Docker image is going to run on the Docker container. So this is the final part of this application. So as you have seen on the screen that in this session, I'm going to, so in this session, basically there is a online shopping portal. And so I think as a user, you also visited, you have also visited plenty of online shopping portals. So you have seen that when you want to shop something online, then first you need to register yourself, and after that you can check the product catalog, and if you like some product, then you order, and then you put all your products in the cart, and then finally you did the payment. So as a programmer, you need to understand that for each part there is one microservice is running in the backside of this application. So for example, for account, when you are accessing the application, you are the account microservice is running in the in the background. Similarly, if you order something, then if you're checking the specific product, then product catalog microservice is running. And finally, when you want to order something, then order microservice is running in the background. So in this session, I'm going to teach you how to code the account service microservice, and I think if you are able to understand this concept, then I think you can easily code the other microservices. So let's go to more detailed part of developing this microservice. So as you have seen in the picture, that to develop this account service, you need 3 microservices. So the one microservice is called account service. So this is going to interact with the database. So let's say that and one microservice which, like, let's say when a customer is going to interact with your e-commerce application, then this web service microservice is running, and then let's say if a user want to access his or her information, then with the help of account microservice, it take a look in the database, and as a developer, you should understand that when your web service is going to interact with account service, it is using RESTful API. And when the account service is interacting with the database, then it is using JPA SQL. So we will check all this part in our coding section. But then in this picture, as you have seen, that there is one more microservice is used, is called registration service, or also called Aureka service. So this service is used for registering these microservice, so that each microservice can discover each other. That's why the name of this service is also called discover service, discover service or Aureka service, or because it is developed by Netflix developers, so sometimes it is also called Netflix service. So this registration service is the mandatory part when you are developing any amount of microservice, because you need this microservice so that the other two microservices are can discover each other. So let's say it is based on the client server model. So all these microservices are the client, and this registration service is the server. So let's take a look inside the code. So here I have used the IntelliJ IDE, but you can use NetBeans or Eclipse. Like you can use any IDE you want. So here, first you need to take a look of the structure of this project. So as a developer, you should see that all the main files you need to place in the main folder. All the testing related files you need to put inside the testing folder. Then there is then, as you have seen in this folder, there is .mavin, because this project, the building tool which is used here is Maven, but you can also build this tool with the help of Gradle. And also for Docker related file, you need to, for Docker related operations, you need a file called Docker file. And then I will explain you later which commands you need to put inside these files, because these two are automatic generated by Maven and Gradle, so you don't need to take care of this part. But as a developer, you should take care of POM file. So here inside the POM file, you need to put all the dependencies you want while developing your microservice. So for example, let's say here I have used the S2 database, which is inbuilt database. That's why I have imported this dependency in my project. Similarly, I have used JPA to interact with the so that my account microservice is going to interact with the account database, and that's why this dependency is here. So all these dependencies are the one which I required while developing my microservice. Okay. So the next important part you need to take care is, then you need to set this is another structure. So inside the main folder, you need to create a Java folder, or sometimes in terms of Java language, we can call it as package. So there is inside the Maven, you need to create the Java package. This is the standard way of coding this microservice, but you can use any structure you want. This is not, there is no hard and fast rule. So for all the three service, you supposed to put all the service inside the service package. Okay. And similarly, because for account service microservice, you can put all the related files inside the accounts package. And if there's an exception, so the corresponding files you need to put in the exceptions package. So let's check each service here. So here inside my service package, I put all the information of or let's say all the main file of these three microservice. So account server, this is a Spring Boot application, and this is also a microservice. Registration service is for the registration server, or let's say Aureka server. And as you have seen that, as you have seen here, that this web service and account service, they are using annotation of enable discovery client, because both microservices are client here and registration service is the server here. So that's why here we have used Aureka server, enable Aureka server annotation. And all these three applications are Spring Boot applications. So it means inside this package there are 3 microservices. And then let's start with the registration server. So as you have seen that it is simple, because it is most of the coding part is done by the Netflix developer. So we just use this annotation, and whenever we call this Spring Boot application, it interacts with the registration server.yml file to check all the configuration of this server. Similarly, for account server, it interacts with the account server.yml file, and it take all the configuration from this server. And similarly for the web server, so all these YML files it has placed in resource folder, but it is, or let's say resource package, but it should be noted that both resource and so both resource and Java. So so these are 2 different packages. So Java package, inside the Java package, I have put all the microservice, all the, let's say, the main files inside this package. And for all the resources, I have put inside the resource package. So here, if I open my, for example, the web service microservice configuration. So here, this is the name of the service. So here all details are mentioned. And for registration service, so as you have seen that to generate the dynamic page, the registration service has used FreeMaker, but web server and account server both are using ThymeLeaf. So ThymeLeaf is used for generating the dynamic HTML, and all the pages, all the URLs are being placed inside the all the URLs are being placed inside the just a second, it's in the URL page. So so here, as you have seen that that all the server related information are being placed in account, and in the so all the Spring Boot related information are being placed here, and all the resources are being placed in the resource package, and all the HTML files which is related to the web server microservice, for example, it is placed in web server templates. Similarly, all the HTML files which is related to account server microservice, it is placed in account server templates. So all the resources are being placed here. So just an overview of all these microservice. So for example, as I mentioned, the registration service don't need much coding part, but as a programmer, you should take care of web service and the account server. So you need to take care of only these two files when you are programming the microservice. So let me close the YML file. So whenever the application is being compiled, it interacts with the main file. So inside this main file, as you have seen that it tries to access, I mean, if the server name is registration, it calls the registration server class, which is inside the service and registration server. And similarly, if it calls to if the account name is web, it calls the web server, and if account name is, and if the server name is accounts, then it calls the account server. and and if I go to so for example, if I go to my account web service, so here it import all the configuration from account configuration, and all these detail present in the accounts package. Okay. And then as per the Spring Boot, the repository is going to access with the help of account repository. And being a programmer, it is good that you can put the comments inside each of your class, so that the other developer can understand that what is the usage of this specific class. Similarly, while you are compiling all these class, you need to put the instance of logger class, so that you understand that when certain operation is being executed, and let's say if something didn't work, then this logger file can show all the logs in the command terminal, and you understand that where is the issue and how to solve this issue. Okay. So for account server, the so like this is the repository for entity. So this account configuration, it looks for the entity with the help of entity scan tag, or let's say entity scan annotation, and it looks inside the accounts package. And here, as you have seen, that this entity is there, and we need this entity so that the user can retrieve all the information on so the information which is presented to the user from account microservice to the web service. This information is present inside this class. So for example, this account number and the owner name and the balance, so all these this database related structure exists here. So, and similarly, like let's say this the data source which which account microservice has taken, this database is taken inside the testdb slash schema.sql. So this testdb is also present inside the resource package. And here we have data SQL, where we have all the entries of or let's say all the database of every user, its account number, for example, the user's account number and username, and this is the schema. So it means like this is how these are the attributes which is used by the account, and this is the information which is being retrieved. As I mentioned that I have used the in-memory database, but this is not a right approach. So every time it is recommended that you need an external database. It should be based on PostgreSQL, the database, or MySQL or Mongo database. But only for explaining this session, I have used this in-memory database. So I think most of the part is covered, and then let's execute all these microservices. So now to execute these microservices, first you need to build this project. So after building this project, a jar file is generated. So a jar file is generated in the target folder. So here, as you have seen, that currently the target folder is empty. So once it is executed, it shows some warning, and then it is scanning the project, and after that, after scanning, it is checking all the resources. It is compiling, and then it is checking all the tests. It has performed all the tests, And after that, so whatever information like dependencies information is present in the POM file, so it is trying to import all the dependency. But because I already have executed this project, so I have information of these dependency inside my local repository. But during the first time, it always take time, because then it is retrieving the corresponding dependencies information from the server. And then here, as you have seen, that it shows these info and warning logs. So these logs, it comes from the logger. So inside the logger, I set the two types of logs, the info and warning. And this is the reason why it shows these, and some of them are also from the system, but some of them is being coded inside each of the microservice. So after that, as you have seen, that everything runs successfully, and now it is testing. So inside the test folder, all these classes are being called, and it is testing each and every method. But because this is a short demo tutorial, so I don't want to go each and every section of this project, but I try my level best to explain the most important part of this project. And now it goes to the database side. So as you have seen on the screen, that it shows warning that it is unable to determine the database version, but it's fine, because in this context, the version of database doesn't matter. And the final is it built successfully. And if it builds successfully, then if I check my target folder, so here you see that all the jar file is being generated here. Okay, so the next thing is to configure the Docker file. So in the Docker file, because I already put this command, that the jar file is being placed in target, and this is my jar file, and rename it as app.jar file inside the Docker image. And then here I have used OpenJDK 8 to create this Docker image. Then I have used these 3 ports. So the one port is for registration server microservice. The another one is for the web service microservice, and the third port is for the account service microservice. Okay, so now our first task is to create the Docker image. And to create the Docker image, I have used this command, and I think I pressed this 2 times. So now if everything is fine, then miu/microservice Docker image is generated. So how you can check your Docker image? So the command is Docker, I think images, but I think just a second. So the command name is Docker images, and here, as you have seen on the screen, that miu/microservice Docker images is created. Now our next task is to create a network. Why? Because this network is used, with the help of this network, all the 3 microservices is able to communicate with each other. And for this, the command is this one, Docker network, and my network name is accounts.net. So now a new network is being created, and now the next task is to is to run each service on each port with the help of this generated image. So here, as you have seen, that our registration server is being running on this IP address, and we need this IP address so that other two microservice can discover each other. And here, as I mentioned, that registration server is the main server here, and the other two web services are its clients. So if everything runs fine, so now our registration server is working. So let me check our first microservice, which is running on localhost 1111. And as you have seen that our Aureka server or registration server is running perfectly fine, but currently there is no microservice is registered on this server. So the next task is to run other two microservice, and to run other two microservice, like that is, the first is account server or web server. Sorry, the first one is account server and the second is web server. So here on this port, my account server microservice is running, and this is the IP address. So this is the microservice which is going to interact with the database with the help of JPA and SQL, and which is interacting with the in-memory S2 database. So I think because it is still loading, that's why it shows this error. But now, as you have seen that this microservice account microservice is running, and then if you want to check whether this account exists, then as you have seen that yes, this number exists in our database, and this is the name of the owner and this is the balance of the owner. But you cannot show this content to your customer, because the customer always want a nice web application, and for this we need our, and this is the reason why we need our third microservice, which will run on port 3333. So here, if I go to my slide, so as I mentioned, so here like our microservice name is web server, and this is the host name, and this is the network name. We just created network called accountsnet, and this is the port where I'm going to run my web server microservice, and this is my Docker image, and this is our registration server IP address. So this is how this command is being written in using Docker. But as you have seen that this third microservice runs on 172.19.0.4 IP address, and still it's loading. So the customer is not going to access your account service microservice or Aureka server, but this is the third microservice which is being used, which is being accessed by the customer, which is running on port. So every time whenever a customer is executing your application, or I want to access the information, so only this is the page which is being accessed by the or this microservice, which is web server microservice. So this is being accessed by the customer. So here, like, let's say if you want to check whether this user exists, so here it says that yes, but as you have seen that it has nice UI, and this is only this part is only in the backend side, but this part is the one which is being observed by the customer. So So similarly, if you want to, for example, check like other informations, other users information, let's say if you want to check like not this one, but want to see whether this account exists. So here, as I mentioned that here it calls this dynamic URL is generated based on time leaf, and here this information is just deployed is being shown with the help of exception page, because this account doesn't exist. That's why it throws this error. But one thing here you have noticed that if I click on this URL, then we can access this page. But like, let's say this is not a good application, because if like anybody knows about this URL, so like let's say this account information is being displayed to any user. So here there is no security. There is no security for that specific user and its credential. So it's always good to put to secure each and every user's information. And as a developer, you should understand that on Spring, it provides a way to secure a user's information. And basically this comes in our next slides. It's called authorization with Spring Security. So here with Spring Security and OAuth 2.0 support, what happens that it access tokens of one app to the another app, so that it ensures that everything is secure and encrypted. It means if anybody want to access this link, so it directly, this page goes to the login part, and then the user need to put its login credential, and if it works, then user access this information. So it means like any, so that only the specific users who has that credential has right to access this page. But as a developer, you should know that there are different architectures of Spring Security. So one of them is called is called as OAuth 2.0. Basically here token relay pattern is being used, and also Java security object signing and encryption and JSON web token standards are being used in OAuth 2.0. Similarly, there is another architecture where one microservice acts as Zul gateway service, and it provides a central authorization, and it redirects an incoming request to the other microservice. So it means always there is always the security is the most important part. But again, we don't I don't have that enough time to explain this concept in this session, so we will keep this part for our next session. So I hope that that you understand the concepts which I tried to explain, and thank you so much for your attention, and have a nice evening.